Students, in this particular class we will learn about sets. Now, sets are actually one of the four important data structures that anyone pursuing Python have to know, and they are also considered to be a powerful data structure. Now what I'm going to do is I'm going to define set here. So let me write that down. Set in Python is one of the predefined data structure available in Python. Now the elements in a set can comprise of any type. So that's exactly what I'm going to write there. The elements of a set can be of any type. When I say any type, I'm talking about they can be strings, they can be numbers, they can be tuples, etc. Now another important feature that you have to know is set in Python are unordered and unindexed. Now I'll explain to you what exactly is the meaning of unordered. In other words, you cannot have a unique indexing, right? So let me state that in the proper manner. So what is the meaning of this? It means that they do not support indexing, simple as that, or slicing. Now you would be able to index or perform slice only if there is some sort of order present in the data, right? But you just cannot do those things when it comes to sets. So that's the reason we say when it comes to ordering, the order is literally undefined for a set, and you wouldn't be able to index the elements. That's the simple meaning. But these attributes of sets differentiates them from lists and tuples. Okay, so that's an important splitting difference. So these attributes of set differentiates them from lists and tuples. So in case of lists and tuples, we would be able to not only perform indexing but also slicing, but in sets it's just not possible. But given that situation, how are we going to access elements? Yes, we can access the elements in a set, and for that we would have to have for loop. I will demonstrate to you how that is done. And another important thing is set in Python are mutable. So that would mean you can push in elements in a set, you can remove elements in a set. So let me write that. We can add elements, or let me write that, and or remove elements. Delete, remove elements from set. So having given you this, there is another important feature that you need to know about sets, and that is they act just like the set in mathematics. A set in Python acts, or I should say, okay, this word will be better, acts like the set in math. right? So that would mean operations such as union, intersection, difference, symmetric difference can all be performed on a set in Python, right? All of these are math operations. So union, intersection, difference, symmetric difference, they are all math operations that can be performed on a set in math. But the same thing can also be performed on a set in Python, right? So we have got a fairly nice picture of the set in Python. So having given you this definition, let me just start off with the first mission. So what's the first mission? The first mission would be, how do we create a set, right? So let me go to the PyCharm environment. So I would just comment these things. Over here, what's the first objective? First objective is to create a set in Python. Alright, this is what we are going to do. So how are we going to create a set in Python? Now say for example 100 meters race list. You can say race list, or instead of saying, I don't want to put in a race list, or race lineup, okay, for semi-finals, something like that. So I'm creating the set for a certain race and the data is being entered, right? So we got Tom, we got Andrew, we got Tate, we got Raymond, we got Chris. By mistake, the person is entering Tate. So this is a set. We are creating a set, and when placing in the data, the programmer is placing Tate twice. Now I'm going to print this up. So print races finals. Okay, I'm saving it. I'm going to execute this. So if I were to execute this, I am getting the window, and you can clearly see Andrew, Tom, Raymond, Chris, Tate. Tom, Andrew, Tate, Raymond, Chris, Tate. So Tate is redundant, but on the output area we don't see Tate twice, we see only once. So there are a few things you need to know here. First, I have given a certain order, right? But that order is not followed. So that would go to show us that sets are unordered. They don't follow any pattern or any ordering. Number two is duplication will just not occur in case of sets. Now that would mean we would use sets as a filtering process whenever we get a list or data filled with duplications, right? Whenever you get lists, the usual way the data is given to lists is that the CSV file would be sent in as a list, and in CSV file a lot of duplications would occur. So we need to clean the data that's performed or that's present in the list, and for that we would need sets. So this is an example that I've just shown you, and this is the way I create the list, but apparently I have a redundancy of the element. When I print that output, that redundancy is annihilated. Okay, So that is fine. Now, as I mentioned to you, how do you convert? This is the next one. Let me comment this off. The next topic we will have to know is how to convert a list to a set and get rid of duplication. Okay, or I'll say duplicate elements. So this is a very good say feature of sets. So what I'm going to do is I need to get an illustration. I need to create a list, and in that list I would have to get, say, the data. So let me just get the data. So in this case, list, and I want to get passwords or give passwords to the list of employees, serve them with passwords. So that's the example. The example is what? Give passwords, predefined passwords for employees so that they can access the database. So what I'm going to do is I'm going to give passwords like this. So 1 2 1 and then 1 3 4, say 1 2 1, again 190 and 1 3 4 5 4 6 and 2 3 4 and 1 2 1 is featuring again, and 7 8 9. Okay, so these are list of numbers, right? Now if you are going to print type of list and then print list password, so you save it, and this is the data element. So the example is we are actually giving two employees, say, a password by which they can utilize, or I would say they would be in a position to access the company's database using these passwords. But I don't want a password to be redundant, so there shouldn't be any repetition. But usually organizations, they have hundreds and hundreds of employees, and to actually find out a duplicate element is not going to be all that easy. So having mentioned that, I'm going to save this and I'm going to run this. So when you run it, so clearly you can see the data type is list, and all the elements that I've just entered, you see that same and ordering is preserved. That's for the sake of list. But now I want to get rid of the duplicates. So how do I get rid of the duplicates? So I'm going to say password refined, something like that, is equal to, I'm going to say set open parenthesis list password. So now the conversion takes place. I want to say print password refined, right? And I want to know the type of it. So type, you get the type, and then you can print it out, print password refined. Okay, so you save this and you execute this. So when you execute this, okay, the first one is the list, the second one is a set. You see that the set is created, and apparently you can clearly see the duplicates 121 is removed. Now what we need to do is we need to convert back the given information, which is now in set form. We need to actually convert it back to list. Now why we are doing this? Because with the list we can do several operations. So I want to convert this back into a list. So password cleaned, something like that, and I'll put a list is equal to list of password refined, and then print password clean list, and then print type of password clean list. So a lot of things are happening here. So I'm saving it. Let me execute this. So clearly you see that this is a list, this is a set, it's converted into a list, and the type is displayed. So this is the procedure you need to follow if you want to clean data. Look for duplicates and make sure the data is cleaned. So this is a lovely example. So what I've done here, I've taken a list, I've converted into a set, got rid of all the duplicates, and then I reconverted back to the set to the list, and then the output has been displayed. Okay, so much so for the operations of conversion and data cleaning. So now let us go into performing operations on a set. So let me just actually comment this off. Okay, so now what I'm going to do is I'm going to be showing you operations on set. So how do you perform operations? So the first and the foremost thing is we need to add elements to a set. Okay, how do we add elements to a set? So I'm creating a set, say movies seen by Jack is equal to, say, Dr. No, live and let die, live and let live, or something like that. Tomorrow never dies. Some Bond movies, right? And From Russia with Love. Right, so these are all some Bond movies. So if you were to print the type, you would get it as a list. And I'm also printing movies seen by Jack. Okay, some spacings. Alright, so I'm saving it, I'm running it. If I were to run it, I would get the set and the type. Okay, fair enough. So now I want to add one more movie. Apparently Jack comes and tells me that he has seen one more new movie, right? So I want to push that into the set. So how do I do that? So go over here, movie seen by Jack dot, use the add command, open, and then you place a double quote, and the name of the movie is Never Say Never Again. Right, so that is being pushed in, and now when you execute it, you will see that Never Say Never Again, right? So this is how you add an element to a set. If you want to add more, you can add one more. You can say Living Daylights. Living Daylights. That's another movie, all Bond movie. So you can simply add it there. Okay, but you will have a problem there. So when you are adding multiple elements, we cannot use the term add. We will have to change that. Instead of add, you will have to say update. And when you are placing them, you have to place them within square parentheses. That's the way you need to do that. So I hope you are catching the point. Whenever you are adding multiple elements, you need to use update function, and then you have to place all the data within square parentheses. So you save it, you run it, and clearly you see Living Daylights, Never Say Never Again. 2 extra elements have been added in the movies list. So that is how you add a element or multiple elements. If you're just adding a element, you use add. If you want to add multiple elements, you use update. Okay, so that is fair enough. Now we can always remove elements from the set. Now I'm going to use the same example, right? Say I want to remove Dr. No. So how do I do that? So I will say print here, say, and give an asterisk just to have some demarcation. Okay, an asterisk, say 10, and then I will say print removing elements from the set. Removing elements from a set. So that's the title. Now how do I remove the elements? We use the remove command. So just go to the set, place a dot and remove command. Under remove, what you want to remove? I want to remove Dr. No. And then I want to print the set movie seen by Jack. Okay, so that's fine. So I'm saving it. So Dr. No will not be featuring as it featured in the original list. See, in the original list Dr. No is featured, but in the second time when the set is displayed for showing or demonstrating the remove function, I have applied remove function and I have gotten rid of Dr. No. So Dr. No is not there. So that's a wonderful way by which we can get rid of elements from a set. Now if in case you want to remove, say, Doctor, instead of saying Dr. No, you want to remove an element, say Dr. X. However, this movie is not featured here at all, right? So whenever you're using the remove function, you are trying to remove a movie which is not featured in the list. Whenever you execute it, you will get an exception, right? I want to show you this exception. You see that this is not in the list, but you have applied the remove function to remove this, and that's the reason you are seeing this exception. Now if you don't want to actually see this exception, right, you can just, instead of saying remove, say you're using discard. So let us see what happens when I use discard. So I'm saving it, I'm executing it. So clearly you can see removing elements. Dr. X is not featured there, yet I am trying to apply, I have executed or I have fired the discard method, but there aren't any errors. So this is a beautiful way, a beautiful a fantastic method that we've got. Discard. Whenever you have a list, or I should say whenever there is a set and elements have to be removed, apparently the elements that you're removing is not featured in the set. So in spite of that, yet you're getting an output, but you're not getting any exception. That's a good thing, and that would prevent the application from cracking, right? So next comes operations. As I mentioned to you, just like in maths, you can perform operations on a set. So I'm going to demonstrate the following operations. So how to perform union on sets, right? Say for example, I'm taking set A. Set A is equal to 1, 2, 3, 4, 5, 6, and I'm taking set B. Set B has got, say, 0, 1, and I want to have a union of set A and set B. How do I do that? So I can declare another set. Set C is equal to set A, and if you want to have a union, this is the sign you have to use, set B. right? That is a sign that has to be used. And then you can say print A union B is equal to set C. You save it, and then you execute it and see what you're getting. You see that A union B is 0, 1 is added. Of course, we have already had 1, 2, 3, so 1 is not redundant. So that is how the union is performed. Now, what if you want to perform, say, intersection? Okay, print asterisk and then say 10, and just to have a demarcation, right? So print the intersection. So how do you perform the intersection? So you go here, set D is equal to set A, and then if you want to find the intersection, you use ampersand, set underscore B, and then you print here, print the intersection of A with B is equal to set underscore D. So the only element that is common for both the sets is the number 1. So that's exactly is got here. You see that? That's how you perform the intersection. So having got the intersection, we need to get the difference. So how do we perform the difference? So from the first set, you remove all the elements that are actually common to both the sets, right? So from here, if I were to take away set A difference set B, 1 would be lost. Apart from that, all other elements would be displayed. So what I'm going to do, I'm just going to copy this and paste it here. This is going to be the difference, and I'm going to declare set E is equal to set A minus set B. So this is going to give me difference. So print the difference A minus B. That's going to be set E, right? So I'm going to execute this. What do I get when I execute this? You see that? 1 will be dropped, other elements will be placed there. 2, 3, 4, 5, 6. Okay, the next comes symmetric difference. Now in case of symmetric difference, what we would do is that we would actually pick up the most common elements that are present between A and B, right? And then we will drop those elements and club the other elements and give the output. So I'm going to say print the symmetric difference. Now in this case, in the previous case, 1 was dropped and the other elements of A was featured. In this case, 1 will be dropped, and together with the elements of B, the net elements would be displayed. So this is going to be set F is equal to set underscore A. Now to place in the symmetric difference, you will have to use this cap, set underscore B, and then over here print symmetric difference is equal to, say, comma set F, right? So let me execute this. Let me see what I'm getting. So you see that 1 is dropped, all other elements including the elements of A, this is the element of B, and the element of A are printed. So that is how you perform the required operations. I hope this lesson is clear. If you have any questions, please ask me your questions. I'll be more than happy to clarify your doubts. Thank you, students. Enjoy your day.